Hello students, welcome to E-Lessons. I'm Kriti, your physics teacher. So today we're going to start with a new chapter, that is Semiconductor Electronics. Now this part of the chapter that you're going to study is the revolution that caused for the technology to evolve in and around the world. The mobile phones that we have, the fast technology that is available at the point of your fingertips is due to the evolution of this semiconductor electronics. Now, as it is really sounding interesting, right? So we will start with the semiconductor electronics. Before we start with the semiconductor electronics, there is one thing that is to be questioned is why or how did this evolve, right? How did the invention or how did the discovery or how did we end up telling something like there is an existence of a semiconductor? We have been studying about what is meant by a conductor, what is meant by an insulator. Or a conductor is an element or a kind of a material that allows the flow of electrons or which can conduct electricity, or we studied that it can pass electricity through them, or they are good conductors of electricity. And whereas insulators are poor conductors of electricity, they do not let the electricity pass through them and there is no flow of electrons. All these things we have been studying, right? So we basically know what is meant by an insulator and what is a conductor. Then, what do we actually mean by a semiconductor? Now, was there no technology before semiconductors? Yes, there were. So, what happened here is we know what is meant by electricity, right? So, what is electricity? It is nothing but the flow of charges. What kind of charges? Negative charges. Now, the flow of electrons, that is negative charges, the flow of electrons from one point to the other point is nothing but the electricity, right? Now, this from one point to other point, when the electricity flows, there is a potential difference that is developed at the ends of the conductors, right? Now, this potential difference is directly proportional to the current flowing in the conductor. That is what we derived in the Ohm's law, alright? By 1948, we had discovered transistors. Now, what is transistors? How did we come into the transistors? That is one of the end products of the semiconductors. So before reaching to transistors, there was something called as a concept of controlling the flow of electrons. Now, we know that in a circuit, the current flows, it means there is a flow of electrons in the circuit. That is why there is an evolution, or that is why there is current in the circuit. Now, this current in the circuit has some resistance, right, for which it is inversely proportional, right? We saw the resistance to be more is the resistance for the flow of electrons in the circuit, right? Lesser the resistance, faster or more is the flow of electrons in the circuit. Now, what is this concept of controlling the flow of electrons? Are we telling that at this point of time or this much electrons have to flow? Now, if I provide this parameter, this much electrons should flow. Is this something like that? Now, let's see what it is. Something called as vacuum tubes was being developed before the discovery of the transistors. These vacuum tubes were also called as valves. So, we came to the discovery of vacuum tubes. They were also called as valves. And why are they called as valves, students? Let me tell you the working of, or let me explain you the working of the vacuum tubes. In the vacuum tube, there were two electrodes, okay? One was the cathode and the other was the anode. Now, we have learnt about cathodes and anodes, which are present generally in this case of electrolysis or in the form of batteries or in the experimentation purposes, right? The same, we had vacuums in the electrodes, right? And now the electrons were supplied by the heated cathode in the vacuum tubes. and the flow of electrons within the vacuum tube was obtained by creating a potential difference between the two electrodes. The electrons were supplied by the heated cathode. It means there is a process of heating that was required in order to emit or in order to supply the electrons required to flow through the vacuum tubes. And the flow of electrons was ensured by developing the potential difference between these two electrodes, that is the cathode and the anode. In the vacuum, there is a requirement of inter-electrode space. Now why? As I told you, the heated cathode emits or the heated cathode supplies with the electrons, right? Now when the electrons are moving as they are heated, it means the kinetic energy is more or it's high, right? So there need to be some inter-electrode space, or I can say that there should be vacuum between the electrons that is been flowing. Now as I told you, see, let me assume this is a vacuum. Okay, this area region inside is a vacuum. So vacuum means there is no air resistance in that, right? Vacuum is no air. There is no air resistance at all, right? It is an empty space. Now, when the electrons, for example, let me assume these are electrons that are being flowing in the vacuum tube, which are emitted or which are supplied by the heated cathode here, and they are flowing because of the potential difference developed between the two electrodes. There needs to be some inter-electrode space. And why? It is because there needs to be vacuum here in between the electrons, because when the electrons are flowing, we do not want the electrons to collide with the air particles, okay, or the molecules of air, I can say. That is why we maintained the space to be a vacuum. As a process that has been explained to you regarding the vacuum tubes, that is that it contains two electrodes, it means that it was bulky. Okay. Now, for the emission of electrons, the supply of electrons, the electrode, that is the cathode, had to be heated up, right? The heated cathode used to supply, or the heated cathode was used to supply the electrons required in the vacuum tubes. Now, and also there was vacuum maintained within the space in the vacuum tubes, especially because the electrons that are being flowing through should not collide with the air particles or particles in the air. That is why the space through which the electrons are flowing are chosen to be vacuum tubes. Now, there are few disadvantages why we came into the next kind of discovery, right? If the thing that we have invented or something that has been useful to us has some kind of inconvenience and disadvantage, what do we tend to do? We tend to think of a better option, right? Now this is what happened here. When vacuum tubes were used, that is, let me give you a simple example where the technology of vacuum tubes was used. If you know cathode ray tubes, which you have studied in your smaller classes, where is a cathode ray tube used, students? It is used in the television sets in the olden days. The olden days television sets, how they were? They were less reliable, they were bulky, they were big, consumed high power, needed high voltage and all that. But what kind of television sets do we have now? They come in the form of inches, the screen size is bigger, they are compact, they are not heavy, they are not bulky, they require less voltage, right? There are so many advantages, that is we have overcome the disadvantages that we experience with the old technologies. That is why we came into the development of the new technology, that is semiconductors. Okay, now what is exactly the semiconductors?